Hi, good day everyone. This video is about solving logarithmic equations with use of our first method, rewriting to exponential form. Again, if you want to solve logarithmic equations or different set of logarithms, our first method is to rewrite that logarithmic form into its exponential form. So again, let's review the concept of logarithm and exponents, right? So for example, we have this logarithm, right? So let's say we have this logarithm of a number a, okay, with the base of b, and that is equals to c. Okay, that is for logarithm. And for exponents or exponential form, we have this given expression that is equals to b, okay, raised to an exponent, and that is equals to a number, right? So again, we have this set of connection. We have this set of b or base for exponential that is equals to the base of our logarithmic form. Okay, and the answer for exponential form, that is actually the value inside the logarithmic expression. Okay, and the value outside the logarithmic expression is actually the exponent for this exponential form. Okay, so this time let's try to solve some exponential or logarithmic expressions with the use of rewriting it. Okay, for our first method, let's rewrite it to its exponential form. So for example number one, right, for example, we are asked to solve this. We have logarithm, okay, of x with the base of 4, and that is equals to 2. Right? So again, same procedure. So let's rewrite this logarithmic expression into its exponential form. So number one is to copy the base. Right? So since the form for exponential, that is b, again that is b raised to c, that is equals to a. Right? So that means we have this first number, we have 4. So for its exponential form, we have 4 raised to an exponent. So we have this exponent as the outer value for logarithm, that is squared, and that is equals to this value. We have this x. Okay, so that means we have this 4 squared is equals to x as the exponential form of this given logarithmic form. Okay, so let's simplify this one. So we have 4 squared is equals to x. That means 4 squared is simply equals to 4 times 4, or simply 16. And that is equals to x. And that's it. So that is our final answer. Okay? So if you want to double check your answer for our checking, so just substitute the value of our answer to our original expression. Since we have this logarithm, we have this logarithm of x with the base of 4, that is equals to 2. So let's try to plug in the value of 16 as the value for x. That means it will give us logarithm of 16, okay, with the base of 4, and that is equals to 2. Right? So if you want to use your calculator, the value of logarithm of 16 with the base of 4 is obviously equals to 2. So if you want to double check this one with use of exponential form, so it will give us 4 squared is equals to the mid value, which is 16, and obviously 4 squared is equals to 16. Okay, and 16 is equal to 16, so that is correct. That means we have this correct answer. Okay, that is for our example number 1. Next, for example number 2, let's try to solve logarithm of x again with the base of 9. This time, let's use 1/2 as the answer. Okay, again, we have this logarithm of x, by the way. Logarithm of x with the base 9 is equals to 1/2. Okay, so let's transform this one. Let's use this method, rewriting to exponential form. That means it will give us 9 as our base. Okay, raised to an exponent. We have this exponent as 1/2, and that is equals to x. Okay, since we have this given value of exponent, again, if you encounter some exponents written in a fraction form, automatically we need to use the concept of radicals. Okay, so this 1/2 is equals to square root of 9. Okay, and that is equals to x. Again, we have this denominator as 2. That means we have this index of 2. right? So for example, you encountered some sort of problems. Like, let's say we have 8 raised to 1/3. That means that is equals to cube root of 8. Okay? So that's it. So again, since we have this given problem, we have square root of 9 is equals to x. Again, the value is simply square root of 9 is positive or negative 3. Okay, so that is our answer. Right, so same procedure. If we want to double check your answer, just substitute the value of x to our given function or expression. Okay, next for item number 3. Okay, so for item number 3, let's try to solve this one. So let's solve for the value of x. If we have this logarithm of x all over 3, okay, with the base of 2, and that is equals to 4. Right, so again, I encourage you to pause this video and try to solve this problem. Okay, so let's try to solve. So again, same procedure. Let's rewrite this given logarithmic expression or equation into its exponential form. Again, we have this base as 2. We have this base. We have this exponent as 4. So it will give us 2 raised to 4. And that is equals to x all over 3. Right? Next is to simplify this one. So if we have 2 raised to 4, that is equals to 2 times 2 times 2, 4 times. I think that is equals to 16. Right? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, next. That is equals to x all over 3. This time we have this rational expression or equation. So let's remove the denominator by simply multiplying both sides of our equation to 3. So let's multiply by 3. Okay, so cancel out 3. Therefore, it will give us 3 times 16. Okay, 3 times 16, that is equals to 48. That is 48, and that is equals to x. So x over 3 times 3 is simply x. And that's it. So that is our final answer for question number 3. Okay? So if you want to simplify or double check your answer, just substitute the value of 48 as the value of x, okay, to our original problem. Okay, that is our example number 3. Next, number 4. Okay, so for example number 4, let's try to solve this one. Let's say we have logarithm, okay, logarithm of, say, 16 with the base of x, and that is equals to 2. Right, so again, same procedure. So let's transform this logarithmic form into its exponential form. Again, we have this base as x. This time, the value of our base is our variable. Okay, that is x. And that is raised to the exponent, which is 2. And that is equal to 16. Right, so since we have this second degree function or expression, this is an example of quadratic equation. So it's up to you. We have 4 methods, okay, to extract the roots of a quadratic equation. So it's either factoring, completing the square, extracting the square root, or with use of quadratic formula. So this time, let's try to use extracting the square since we have this degree as 2. Okay, so since we have this x squared is equal to 16, right? So let's extract the root, square root both sides. Okay, so cancel out the radical sign and the exponent. Therefore, it will give us x is equals to, so square root of 16 is equals to positive or negative 4. Okay, that is positive or negative 4. Now, since our next step is to double check your answer, so we need to substitute the values of our x to our original expression. Since we have this positive and negative 4, actually, negative 4 is not valid. Okay, it is not a solution. Why? If we use x as negative 4 as our base, again, according to the concept of exponential function, the base of an exponential function must be greater than 0, and that is not equals to 1. So automatically, all of the negative values are not qualified. Okay, we need to disregard those values. Therefore, x raised to x as negative 4 is an extraneous solution. That means x as positive 4 is the correct answer. Okay, that is our final answer for this item number 4. Next, let's try to solve item number 5. Okay, so for question number 5, okay, let's try to solve this one. Let's say we have this logarithm. Okay, let's say logarithm of 2x minus 1 with the base of 3, and that is equals to 2. Okay, so let's transform this one. Let's rewrite this logarithmic function or equation. Then copy the base. We have 3. Raised to 1 exponent, we have squared. And that is equals to 2x minus 1. Okay? So let's simplify this set of expressions. So we have 3 squared, that is equals to 9. And that is equals to 2x minus 1. Since we're looking for the value of x, we need to isolate the value of x. Okay? So I think we need to remove this negative 1. So it's up to you again if you want to transpose the value. Okay? So if that is your technique, that is okay. Again, our goal for this part is to solve for the value of x. So we need to isolate it. So I think by applying APE, to remove negative 1, I need to add 1 both sides. Okay? That means it will give us 9 plus 1, that is equals to 10. And that is equals to 2x minus 1. Okay, 2x minus 1 is plus 1, by the way. Cancel out negative 1. And that is simply equals to 2x. Next, since we have this 10 is equals to 2x, divide both sides by 2. Okay, cancel out the value of 2. Therefore, the value of x is simply equals to 10 divided by 2, and that is equals to 5. So that is our answer. Okay, so again, same procedure. If you want to double check your answer, just transpose or substitute the value of x to our original logarithmic function. Right, so let's proceed to item number 6. Right, so for question number 6, say we have this problem. Again, let's say we have this logarithm or log of, say, 2x squared minus 1. Okay, with the base of 7, and that is equals to 2. Okay, so let's try to solve this problem. Again, we have this logarithm of 2x squared, okay, quantity of 2x squared minus 1 with the base of 7, and that is equals to 2. So let's transform this. So again, copy the value of our base. Our base is 7, right? So that is raised to the value of 2, and that is equals to 2x squared minus 1. Okay, so again, let's simplify. Since we have this 7 squared, so that is equals to 49 equals to 2x squared minus 1. Again, so we need to isolate the value of x. So let's add 1 both sides to cancel out this negative 1. Okay, so it will give us 49 plus 1. That is equals to 50 equals to 2x squared. So cancel out negative 1 and plus 1. Okay, next. Since we have this value, we have 50 is equals to 2x squared. I think we need to divide both sides by 2. Okay, so cancel out the value of 2. So it will give us x squared is equals to 50 divided by 2 is equals to 25. Right, so this time we have this second degree equation or function. We have this x squared. I think we need to extract the roots. Okay, so square root both sides. Okay, so cancel out the exponent. And that's it. So the value of x is simply equals to square root of 25 or positive or negative 5. Okay, this time, since the value of our roots or x is positive or negative 5, so if you want to double check if you have this extraneous solution, just substitute the value of that x to our original expression. Since we have this x squared, okay, so if we substitute the value of x as negative 5, automatically negative 5 squared is equals to positive 25. So that is okay. So the solutions for this given problem, we have negative 5 and positive 5. Right? So again, that's it. So that's the entire procedure. So if you want to solve logarithmic equations with the use of rewriting it, okay, to exponential form. Right? So again, same procedure. Let's substitute or transform the given logarithmic function into its exponential form and solve for the values of x. Right? So thank you again, and God bless.